We are back. Yeah, we're back. Just a few minutes. I prepare everything for the next session. All right, welcome back, everyone. So this is about Motoko, the programming language we will use this week. And there are a few things that you need to know, whether it's your first language or you're already experienced with other languages. There are a few things we need to talk about because Motoko is a special language since it's a language made to build on the internet computer, and the internet computer is a special platform. So this session is about 50 minutes long because we have a lot of subject to cover. It's probably the most important lecture of the week because it's the foundation for everything that we are going to do, and also it's very dense in terms of information, like how many things you will learn in this hour. So stay focused. Make sure that you ask questions. I'm monitoring the chat if there is something you don't understand. And also, this will be available after this session is over, so you can rewatch the video if you have missed a few things. We will start in 4 minutes. I'm waiting for everyone to join, and then I'll start the session, and we will start with Motoko. So I'll provide the link to this video at the end. And also, this is on the training repository. So this this is actually one of the resources that you have for day one. You will see a list of lectures, and this one is included. All right, so for those of you that have just joined, I was saying before that this is one of the most important lecture for the whole week because there are a lot of topics that we will cover today, and also it's a foundation for everything that we will do during the rest of the week. So keep your eyes and ears open, and we will start in 1 minute, just so the last people can join. And also if you have questions, Q&A and chat as usual. All right, everyone is here, so let's get started. I'm still here, and I see you in a few minutes, in 1 hour. Okay, so we have an issue with the sound. Now it should be better. Okay, let me know if it's good now. So I was saying, let's jump into this session. This is an introduction to Motoko. We will talk about what is Motoko, how we can build and write the code for canisters on the internet computer, how we can set up the environment. We will talk about DFX. We will talk about Candid UI, functions, variables, and types in Motoko. So this is a 1 hour session. It's recorded, and this is very important. It's like the basis of Motoko. If you need to watch only one session this week, this is the one. So keep the eyes and your ears very, very open. If you have questions, Q&A, we will be doing 10 minutes of Q&A at the end of this session. So you should be able to see my screen, and I have the minimum setup for building a canister in Motoko. The minimum setup consists of 2 files, which is main.mo. This is, of course, a Motoko file. .mo is a Motoko file. And the second file that we will need is a dfx.json file. This is a configuration file for dfx, and dfx is a tool. So if I go here and I do dfx version, for example, this is a tool that I've already installed on my machine, and I have version 0.15.1. I think the latest right now is 0.15.2. dfx is useful for building code, compiling code, and deploying canisters on the internet computer, and also managing them. Before we start, what is Motoko? So Motoko is a new programming language, and I can actually show you maybe. This is our repository, and we actually have some chapters. The chapter 1, it's in lesson chapter 1. What is a canister and WebAssembly and Motoko? So that's here. Motoko is a new language that has been created by the Definitive Foundation. So the Definitive Foundation is the foundation that has created the Internet Computer Protocol. And it's a programming language designed for creating dApps, so decentralized application. Motoko compiles to WebAssembly. So WebAssembly is this, looks like this. It's a virtual environment. Just like on Solidity, you have the EVM environment, the EVM virtual, the Ethereum virtual machine. On the internet computer, the virtual machine is WebAssembly. So WebAssembly is actually a really interesting technology. If you are not familiar with it, I strongly recommend you watch. There are some really good videos on YouTube about WebAssembly, like 10-minute videos. WebAssembly is going to be a huge thing in the future. It's a standard for essentially running code in multiple environments. So you can run WebAssembly in your browser, you can run it on the cloud, for instance, on the internet computer, on smart devices, and all sorts of virtual machine. Essentially, it's kind of the ultimate virtual machine because it supports a lot of languages. So C, C++, Rust, Motoko, and many more languages in the future. And also WebAssembly run on any device. So the image that I've created here to, make it clear what is the purpose of WebAssembly. It's the solving this problem, which has been painful for developers for the past 40 years, which is that you need different source code if you're trying to run an application on different platforms. So, we have different standards like x86, x64. Now with the MacBook and the mobile devices, we even have a new standard, which is RAM. And so all those chipsets, they require a different source code. So that's 3 code base that you have to work on, and even more if you are supporting different OS and different platforms. With WebAssembly, you just write your source code once and you just compile it to a WebAssembly module, and that's running everywhere. So that's a super cool standard. And also WebAssembly has a lot of advantages, like it's really fast because it's very, very low level. It's optimized for speed and performances. So you can run like complex application in your browser, like games, simulations, all sorts of things. And it's a secure environment. It doesn't mean that you cannot create code that is not secure, but it has a concept of module, and modules can only access specific resource in WebAssembly. It has been built with security in mind, which is super important for something like blockchain, for example, where we have a lot of money, financial applications. We don't want to, we don't want to have a unsafe environment. But no one sane would write WebAssembly because it's a low-level language, and you don't want to write WebAssembly. If you are curious, you can check it out. There is actually one, I think it's the only one example in the Motoko, in the Definity/example repository. There is one example of a canister written in WebAssembly. This is this. It looks like this. So if you are curious about WebAssembly, you can take a look. Yeah, I don't recommend to. If you are curious, you can take a look. I will put the link in the chat. But essentially, it's just for the fun. No one would really use that to create scalable applications. And that's why we have Motoko. So we write our source code in Motoko, we compile that to WebAssembly, and then this is what will be installed on the canister. Fun fact, Motoko was created by Andreas Rosberg, who is also one of the brain and the mind behind WebAssembly. So the idea is that Motoko was created for WebAssembly in mind. And that's why it's so cool and so powerful as well. So a file with the extension .mo is a Motoko file. So, oops, sorry. That it looks like this, and Motoko is a high-level language. Let's go. So the first thing that you want to do with a Motoko file is always start with the actor keyword and then open brackets. And that's where we will write our functions, because a canister, so this is the code for a canister, is an actor. And if you don't know what is an actor, you can take a look at this article. I think it's on Wikipedia. It explains the actor model. It's a theory in computer science. Essentially, it's just saying that each canister has a private state, and you can only reach the private state of a canister like through messages. So the memory of canister A is not accessible directly by canister B, and they have to send messages to each other to communicate. And that's how you build applications on the internet computer. You create canisters, and you make those canisters communicate with each other. So I'll be also sending this link. Keeping track of all the links we are using today. Okay. Then Motoko is a typed language. So statically typed language, which means that every variable and every function will have a type, and you have to respect this type. Let counter of type nat is equal to 0. This is how you would initialize a variable in Motoko. This is an immutable variable, so we can never change it, which is maybe not a good idea for a counter. That's why probably you would use var at the except of let. Then here I'm specifying the type. I could also define my variable like this. There wouldn't be any problem. But I like, and I recommend you do the same for the whole week of the bootcamp, that you always use the type, that you specify manually the type of each variable you declare. This way you will keep in mind that, okay, every variable I'm using, there is a type associated with it, and you don't mix it up. Okay, then let's create our first function. And so we want to make the function public, which means we can access it from outside of the canister. And we want to increase the counter. So I take no arguments, I return nothing, and I will just do counter is equal to counter plus 1. And then I return. Okay. And then I will create a query function, get counter. Oops, this is not the correct syntax, by the way. I will, I just want to, I will disable completion for just for this session. So as you can see, even the types need to be specified in the functions. So here we are returning the counter. And so counter is of type nat. And so that's why I need to specify asynchronous nat. If you are not familiar with asynchronous, it's the same as you can have in JavaScript, you know, async awaits, or in other programming languages. Essentially, it's just saying that when you call a public function, you need to wait a little bit. What you will receive is a promise that you will receive an answer later. Because when you call a function, you are not sure that you will receive the answer, you know, instantaneously. So that's why you need this async. Every public function returns async something. Okay, so now that we have our canister, and it's a really basic one, and I will add more functions later, but let's try to deploy it. And so to do that, we have 3 places we can deploy. We have locally, we have the playground, and we have the internet computer mainnet. Let's start locally. And to start locally, I will start a replica on my machine. To do that, I will run dfx start. And I recommend to add the clean flag, so -- clean, and this will start a replica. Okay, I have an issue, failed to load dfx configuration. Apparently, there is nothing in my dfx.json. And that's on purpose. If you want to use dfx, you need to have a dfx.json file. And so this is how you create one. So you can take a look. For example, let's say, if you take a look at the main repository of the week, the DAO adventure, you will see that I've already created the fix.json for you. And so this is how you would create one. So it's a JSON file, JavaScript JavaScript notation. And so we have essentially a list of canisters. So you can see canisters and then opening the brackets and then all the canisters of the main repository. So level 1, level 2, level 3, level 4, and 5. So for our application of today, we only have one, and we will call it first canister. And we need to specify two things: the main, which is the entry point for the Motoko compiler. And so to do that, I mean, we only have one file, so we need to specify main.mo. And then the type of the canister, which is Motoko. Then we are not using any package manager for today. We are just using raw Motoko. We don't have any imports. So I will remove that, which should remove this issue. And now I can try again. And this is working. So it's running a local replica. And we have the dashboard, so we can take a look at it. Internet computer replica dashboard, subnet replica version, canisters, and everything. What we see here is a copy of the internet computer. So the, you know, this network that is running on our machine. Of course, it's not the real network. It's just so you can deploy things locally and you don't have to pay for it and you can try things. Now we have just started the replica, and you need to have always a terminal that is dedicated to your replica. So you have to essentially open a new one, like this one for my replica and this one for the rest of my actions. And now we can deploy our canister. And to deploy a canister, you need to run defx deploy, the name of the canister, first canister in this case. And then there are more options, like if you deploy on the mainnet, on the playground, you need to add some options. But if you are deploying locally, it's only like this. The first time you deploy a canister, it will create a wallet. So a wallet is essentially, it's a way for you to have cycles, and I will explain what are cycles exactly, but those are like credits that you need to have to deploy canisters. Then it's creating a canister for you, so you receive an ID. This is the canister ID that I have. Then it's building the code and installing the code in the canister. And I can show you, now we have a cache folder, so this folder has been created for us. And this is where you will see the WebAssembly module I was talking about. Oops. If you take a look here, we have the WebAssembly module. We cannot say, we cannot see much, like there is nothing. If you want to see something, you need to click here. Save as a WebAssembly text file. So it will create .wat, and then you can try to look into it. But it's, yeah, this is essentially very, very hard to read that, and we don't really need that, but I just wanted to show you. So this is what is actually installed. Then installing the code, and then it's deploying it, and you have this link, which you can click on it, which is the Conid UI and the Conid interface. And this is a virtual, no, it's auto-generated visual interface for your application. And so every time you deploy a canister, you will also have this interface created for you. And we can interact with our canister from this place. So I can get the counter. So this is 0 right now. And I can increase it. So up, and then, okay, 1, I can try again. And 2, and that's it. And so if I share this link with you and I won't do it, you are not able to access my canister because this is a local canister, and so it only exists on my machine. I would be able to share it if I added some like way for you to reach out to my machine, but we won't do that today. So this is only running locally. Now I want to talk about the difference between let and var. And I've already talked about that before, but just to make things clear, we have two types of variables in Motoko. So This is a mutable variable declared with var. And this is an immutable variable. And so if I try to use this, you will see that it will throw an error because, let's see, expected mutable assignment target, and it's not mutable. So as you can see, when you use an immutable variable like this one, you can never change the value of this variable. So why would you do that? Because sometimes you have variables that you just want to store, but you don't need to change it. For example, maybe I want to store creator name. I want to store who created this canister, and I will just store my name, and then I can use that here. For example, I create a query function, get creator name, and it returns a text, which is the name of the creator. Oops. Okay. Now I can deploy again. Why not use const? I don't know, that's just a choice they've made. So it's, yeah, it represents a const essentially. And now I return my name, so this is nice. Okay, now the difference between this function and this function is very important. Update function can change the state. Goes through consensus. This is what we call an update function. And so an update function is a function that is able to change the state. And the state is actually the state change is retained. And so when we want to change the state of a canister, we have to go through consensus because the internet computer is built on top of a blockchain. And so we need to go through consensus to actually change the state of a canister. For example, here we are changing the state of this variable. And so we need to go through consensus. And that's why you will see this takes around 2 seconds. Yeah, 2 seconds. Whereas this, I just immediate, like it takes a few milliseconds, and that's very, very fast. Because this is an update function, and this is a query function. And so query function cannot change the state. Read only. Doesn't go through consensus. Takes around, depends, 100 to 200 milliseconds. Okay, so now let's make things a bit more interesting, and we will change the place, the network we deploy. We will deploy on the playground. As you can see, it's creating a canister ID. And this time we can see that the link is different. If we go back here, we can see that it's 127.0.0.1, which is, well, essentially your local host. So this is local, but this is not local. As you can see, canister ID dot row dot icp0.io. So this link, actually you should be able to access it. So I can send it in the chat. You should be able to click and call my methods. So for example, you can increase the counter if you want. And I'm sure that if multiple people do it at the same time, we will see, like, I don't know, right now it's just one, but yeah, should be able to see, maybe someone will do it. I'm waiting. Okay, yeah. So someone clicked. someone else. We are at 4 now. And yeah, that's what I wanted to show you. So what is the playground? I received this question a lot. The playground is on the mainnet. Like, the thing is that on most other chains, you will have the concept of a testnet. But on ICP, it's actually really hard to make a testnet because there are a lot of machines, like the nodes, and it's really hard to replicate how communication between nodes work, how the subnets, like how things are defined. It's really, really hard. And it's not also the best experience for developers because there are also like canisters that live on the mainnet. For example, the ICP token is actually a canister on the internet computer. There is the governance canister, the NNS, like all those canisters are living on mainnets. And if you want to interact with them, you need to be on the mainnet. And that's why the playground has been created. It's a place where you can deploy for free. So kind of like a testnet, but you can actually, it's actually part of the internal computer. Like it's the real network. The main difference is that when you deploy on the playground, your canister has a time limited lifetime. So after 20 minutes, this canister will be destroyed. And also you have a few limitations. For example, you cannot transfer cycles to other canisters, of course, because otherwise you would be able to empty the playground. So cycles are credits, and credits that is needed for running applications on the internet computer. When you deploy on the playground, it's completely free, but you have those limitations. So we've seen that we can deploy locally, we can deploy on the playgrounds. Finally, we can deploy on the mainnets, but not on the playground. If you want to do that, you need to do dfx deploy -- network IC, and then the name of the canister. This costs money, so around $1. And if you don't have a cycle wallet set up, you won't be able to do that. And so now, let me see. Yeah, it has created a canister. And so when you deploy on the mainnets, not the playground, but the rest of the mainnets, you will see this file, which is automatically generated for you, canister ids.json. This is your canister, and this is the ID of it. But this one is really forever. Like, I mean, except if I delete it, it's forever on the mainnet. And so I have a link, as always, the Candid UI. And we can, again, see all the functions that we have. So increase counter and get counter and so on. Now I want to show you a few things about dfx. So what is possible to do with dfx and why do we need it? So dfx, if you need help, you can run this command, dfx help, and you can see all the things you can do with dfx. So it's the Definity SDK. So it's the SDK that you will use to build, deploy your canisters. Build, you can do dfx build, you can do dfx deploy, dfx dependencies, dfx identity, dfx ledger, and so on. If you want to, you are curious about, what is dfx identity used for? Manage identities, used to communicate with the IC. Setting an identity enables you to test user-based access controls. If I do dfx identity, then there will be, subcommands. And so if I want to see how to use the subcommands, you can again do a dfx identity -- link. And then you have all the commands. So dfx identity, deploy wallet, get principal, who am I, rename, and so on. dfx identity is really important because every time you are using dfx, you are associating an identity with it. And so we can, for example, see the name. This name, this is the name for my identity, makes sense. And then your identity has a principal associated with it. So this is my principal. The principal is derived from the public key and the private key, the public key. So it's a public information. You can, there is no problem in using this. And it's essentially, a way to, represents your identity when you deploy canisters and interact with them. So, for example, if I take a look at the Internet Computer dashboard, which is here, it's a dashboard that contains information about the number of cycles burned per second. So this is representative of the activity on the network, the number of canisters deployed, the number of transactions per second, and so on. You can also search for any canister. And so this is my canister ID here, the one that I've deployed on the mainnet. I can go here and it gives me, for example, my interface. So you can see the Cornid UI. You also have the Motoko representation of this. You also have other languages, Rust, JavaScript, TypeScript. So if you want to interact from the front end, you can also use that. And you have the list of controllers. So this is the people that control the canister. A canister can be controlled by one or multiple developers. No one, if you remove all the controllers, then the canister is essentially like a smart contract on Ethereum. You have no one able to upgrade it or delete it. Or a canister can also be controlled by another canister, and that's how you can build a DAO. And I will go into more details in the next sessions. Then you have the subnet, and this is our subnet ID. So this is actually where our canister is deployed. You have multiple subnets on the Internet Computer. This one, we have a few information. It's storing 200 gigabytes of data. There are 13 nodes in the subnet. There are 1,569 canisters, and that's the activity on this subnet. And then, oops, where is my, okay, I need to go back. And then we have the module hash, which essentially corresponds to the SHA-256 of the WebAssembly module of the hash of the WebAssembly module install on the canister. So those are basic information, and you can see that this is the same that we had here. So this is my identity, and this one is, so this is my, if I do defix identity network IC get wallet, this is the same identifier. The wallet is not the identity. Why? Because to deploy canisters, we need cycles. And so cycles are credits that are used to pay for computation and storage cost on the Internet Computer. And for example, if I do, let's say, let me see. This is a command to receive informations about our canister. And we don't have the cycle balance. Okay, I wanted to have the cycle balance. Maybe status will do it. Okay, yeah, apparently we have it. Okay, so you can see that my canister has a number, something called balance, which corresponds to the number of cycles that are inside the canister. And so this is 3 trillion cycles right now. This is the default value that is sent when I create a canister. You can change it to 1 trillion or 2 trillion or even more. This represents around $5 worth of cycle. And this is what enables the canister to live and to pay for its storage and to pay for its computation. With $5, this canister will, I mean, there is not a lot of storage, like it's just a simple variable, and probably there won't be a lot of activity here. So this is enough for like storing that almost forever. And what I wanted to touch on is that only your cycle wallet, so where is it? Yeah, let's do it again. Get wallet. Only another canister is able to store cycles. So your identity, like your default identity, is not able to store cycles. That's why you need this cycle wallet, which is just a canister that you control. This canister all your cycles for you and use it to send it to other canisters. Okay, so that's about it for the cycles. If you want to add cycles, you can do it from the FX as well. You have a command to top up your canister. Maybe we have some questions already. How long is this lesson? We will have a break. Yeah, the break is only at the end of the week. Okay, I can see that we have some Q&A. Motoko code is compiled to WebAssembly. Yes, that's correct. What is a boundary nodes? Boundary nodes. Yes, so someone has seen on the dashboard that we have this concept of boundary nodes here. So the boundary nodes, and this will be the topic of the day 5. We'll talk about that. The boundary nodes are what enables users to access the internet computer. So you have the nodes that actually run the consensus and the one that essentially run those canisters. But those nodes are not accessible directly by users. And users go through boundary nodes, and then boundary nodes connect to the consensus nodes. Actually, boundary nodes are super important for a lot of reasons, like, for example, rate limiting. If someone is trying to attack the internet computer, like sending a lot of requests, the boundary nodes will make sure that if it's coming from the same identity, that we limit the rate. So it's a protection layer. Also, it translates HTTP request to actual ICP request, because consensus nodes, they don't have a HTTP gateway. They don't answer directly. So for example, when you access this web page, like the Candid UI, which is built on the internet computer, not this one, because this one is locally, but this one, what we are doing here is sending an HTTP request, right? And so we need those boundary nodes to be able to translate that to an actual ICP request. And also they do like many things. So they do cache, for example, which makes it faster to access website on the internet computer. And those are, right now, they are all deployed by Dfinity. But next year, around Q1, anyone will be able to run the boundary nodes, and anyone that runs a boundary node will be rewarded for that with ICP tokens. The idea is that a boundary node is really light to run. The consensus nodes are not, because they run a lot of data. They run complex calculation. So there is a cost to it. The boundary nodes, they just like do a little bit of caching and also route the request. So it's not the same. And actually, I think you should be able to run a boundary node from like a server that you have at home, or maybe even a Raspberry Pi. And so this is going to be open to anyone. Right now, it's not, because of some technical limitation, but this is in the roadmap for Q1 2024. Okay, let's go back to Motoko. So right now we haven't imported anything. We have just worked with the base of the language. But of course, you will want to work with modules. So modules are pieces of code that someone else has written in Motoko, and you want to use it for your own purpose. And so there is this concept of the base library, which is here. Yeah. I will share that in the chat as well. So those are the lists of modules that we could import. For example, let's say NAT. And those are the list of functions that we have in the module. So for example, we have NAT to text. This takes a NAT and it returns the textual representation. Let's try it out. So if you want to import a module, you need to do it like this. Import NAT, mo base /NAT. Would be, if we import text, it would be import text, mo base /text. This is how you import, but this syntax only works for the base library. And the base library is everything that is here. Those are like, yeah, let's go back. All those modules are from the base library. So you have array, character, buffer, boolean, all sorts of types. Let's import that. And then maybe we want to create a function, public query function, get the counter as text. Instead of returning the counter as a natural value, we want to return it as a nat. And so we could do nat.toText of the counter. And that should work. When you deploy a canister for the first time, you will pay for the deployment, the initial deployment. But then I've seen a lot of people worry about the cost, like, oh, what if I deploy again and like, how am I going to pay? You don't pay for like further deployments, like only the first time, but this is costing nothing. Like, I don't recommend to do it because it's not clean. You should probably test first locally and then when you're ready, deploy on mainnet. But I had instances where I deployed like a canister like 100 times on the mainnet just because I didn't want to work locally. And this cost absolutely nothing. Like, don't worry about deploying multiple times. And if you worry, you can always check your cycle balance with the dfx command. Okay, so I have updated my canister. And as you can see, when you upgrade the canister, the value of the state is always lost. So if you remember, we had previously increased the counter to, I think at some point it was like 1 or 2 or something like this. But because we have upgraded our canister, now we are at 0 and we can increase. This time it will be retained. So 1, and that's it. It works. But when you deploy again, you lose your state. And we will see how we can prevent that. There are ways to, there is something called stable memory, which enables you to not lose the state of your canister when you upgrade it. But by default, everything that is declared, every variable, is reset to the original value. And let's try our function, get counter as text, and this is 1, but as a textual value. So if you want to learn more about the modules that you can use, you have, where is nat? Yeah, all the documentation is here. And you can see that it explains what is a nat. So a nat is actually a special type in Motoko because contrary to most other programming languages, nats are infinite numbers, like they are unbounded. So you can never overflow with a nat. The underlying memory representation will grow as the nats grow. It's not necessarily the most efficient, but it's so well optimized that I recommend actually to use nat. You have other like natural numbers, like you have nat8, nat16, nat32, and nat64, but actually I very, very rarely use them because except for like binary operations, I won't use them because the memory, like the optimization of the nat is really, really good. So I just use nat and I don't have to worry about is my nat going to overflow or not. And here you can take a look. You have a lot of functions like nat.equal, nat.less, and add, sub. Of course, you can do like public func add to counter, and we will take a nat and just add this nat to the counter. You don't need to do, oops. You could do this, like, where is this? Yeah, we could do that. Counter is equal to nat.add of counter and n of variable. but you can also do that. I mean, that's the same syntax. And we can check that we have, yeah, it's here. Add the counter, we will maybe add 10. As you can see, the value of the counter has been reset once again. And we are now at 10, yeah. Otherwise, you would have been at 11, I think. Okay, so I think I've touched upon everything I wanted to touch upon for the first lesson. And there are more types that we haven't talked about, but we will talk about them in the next sessions. Like, for example, you have the type Boolean, which represents true or false. You have the type array, which you will use like this. So this is an array of natural number, for example, like 1, 2, I think it's like this. Yeah. No, maybe it's like this. Yep. You have other types. For example, for the level 1, you will need to use the type buffer. I can already spoil you a bit. For the level 1, you need to get familiar with this type, which is called buffer. It's actually a class. And so that's how you define a buffer. You will need to import the buffer module from the buffer base library, and then create a buffer like this. Let buffer is equal buffer dot buffer. I know it sounds like a strange syntax the first time you see that, but actually it makes a lot of sense. What it means is that you are importing the class buffer from the buffer module. So this is for the module, and this is for the class. And then you need to specify what is inside the buffer. So for those of you that are not familiar with a buffer, you can think of it as just somewhere where you can add things, like you can add values, kind of like an array that would grow. And so, for example, in this case, we want to have a buffer of natural number, and so we would specify buffer.buffer and then the type inside the buffer. And this is the initial capacity, so you could set 0. It will automatically grow as you add values. If you wanted to store text, you would do this. If you wanted to store Boolean, you would store this like this, and so on. Now, let me answer the question. I've seen a few questions in the chat. So we have answered about the boundary nodes already. Oh. Hey, yeah. Ariane, you can, Ariane, I don't know if it's Ariane or Ariane. Srivatsa, sorry for the pronunciation. You can talk. You have a question? You are muted just in case. No, it's all right. Okay. Sorry. Motoko code is compiled to WebAssembly. I am using CanDB. Okay, if you are using CanDB, this is not a question for today. This is something more advanced. This is an introduction session, so I will only take like introductory questions. How could I pass a WASM to the blob? This is all right. So I am back. Those are, oops. Sorry. Yeah, I was saying I am here. Those are old questions from a previous Motoko Bootcamp session. So if you have questions, let's answer them right now because yeah, those are like older questions. Does the Existence of buffer mean that arrays in Motoko can only be a fixed size, or can arrays be added to over time also? That's a good question. In Motoko, arrays are fixed size objects. So I will show you the array library. Here. If you're looking for a data structure that grow, arrays is not what you're looking for. Array is really for storing something that you don't plan to add very regularly. So there is a method called array.append, which you can use if you want to add elements to your array. But essentially, it's going to copy all the elements in your array 1, copy all the elements in array 2, and put all those elements in a new array. So it's not very efficient. If you do it in a loop, it's very, very unrecommended because it can very quickly become very complex. So yeah, array, I think that answers the question. Array is a good object in Motoko for storing, but not for adding elements. If you want to add elements, you can use buffer. So actually buffer is something that we use in the first day, in the project number 1. Buffer, you can do buffer.add, and it simply add an element at the end of the buffer. It's, as you can see, the complexity is very simple. It's constant time. And you can also use list, but lists are a bit more complex. Those are functional structures. So yeah, if you are familiar with functional programming, you will be very comfortable with list. Otherwise, you can use buffer. So the question, yeah. So the question from Mike as well, are arrays mutable? So that's what I said, not really. You can add elements with array.append, but this is really not the recommended way because it's very complex. It's not an efficient operation. Like all the elements from array 1 are copied, all the elements from array 2 are copied in a new array. So you can do it for very specific situation, but not if you're trying to grow something. Oh, can you change the values within the array? So it depends if you have a mutable or a non-mutable array. So there are two types of array. You have the mutable array, which are the array that you would define like this with a var inside, and the non-mutable array. So actually, I can show you, maybe with the Motoko playground. You would have, let's say, let's immutable array. Let's say 1, 2, 3. So like this. So those are two different arrays. This one, of course, is immutable, and this one is mutable. So for example, we would be able to do mutable array, let's say index 1 is equal to maybe 0. But we wouldn't be able to do that here. So immutable, yeah. expected mutable assignment target. So we cannot change that, but we can do that. And so if we do that, we would have 0 here instead. So it all depends on how you define your array. And so this is a mutable array, and this is an immutable one. How are elements indexed? Just like in any other programming language, it's indexed from 0. So this is number 0, this is number 1, this is number 2. Okay, so I'm taking the question from Radu. You're saying you cannot submit your canister? Mm, you probably need to go. So here, you need to click on the left. So initiation, you will have a form to submit your initiation. Training, you need to click on training, and then you need to click on the project that you want to submit, and graduation. So, I mean, for me, I've completed those projects already, so I don't see the form, but you should see the form in your case. I hope that clears up the confusion. Okay, so this is now end of this session. Now we have 2 hours of break, so it's time for you to finally dive into the repository, rewatch the previous video if you haven't started the repository in Gitpod or locally, and start to read the instructions, start to see how the project looks like, and you have 2 hours before the next session. Actually, I've moved the team building for the end of today. The team building session, I want to do that at the end of the day. So we have 2 hours, and then we will build the level 1 together. So for the next 2 hours, well, take a break, look at the repository, the training repository, try to look at, you know, how it's structured and everything. And if you have enough time, start to code the project of level 1, project 1. Yeah, one question. I can take one question. Mohamed, do you have a question? Yes, for sure. Of course, if you haven't done initiation first, you need to be doing it now. And whenever you finish your initiation, it should unlock the training. If it doesn't unlock automatically, that's strange. I'm going to verify that, but you can refresh. Yeah, you can refresh. If you have like you should have a confirmation message that it's okay, and then you should be able to see this. So that gives you access to OpenChat, which is an application built on ICP. You can click here and you should be able to join our community. And you should also have the training that unlocks. If it doesn't, you can just refresh, maybe log out, log in again. Yeah, make sure you enter the canister ID. All right, good luck everyone, and I see you in 2 hours.